Okay, so we will start, and this time we were discussing about HBase, and we are only left about discussing the architecture uh, and how we install it, and some of the basic administrative commands that you will require when you are working with the HBase. We will try to keep this session short because I see a lot of I see two of you, the group are not present, but we will cover up HBase uh, in this session itself. And starting with next session, we will start with the Spark, uh, and we will discuss about the security aspects of the Hadoop. I think we are just left with 2 more weeks at max to discuss the theoretical aspects. After that, we can take a session on Linux commands at advanced Linux or shell scripting, and then we can start having our mock tests just like the one that we have in previous week. Okay, so architecture of HBase, just a quick recap of what we discussed the last time. So we discussed about what exactly is NoSQL or not only SQL means, and we discussed the difference of how we can store a table, employee table, in a SQL format, which is basically when we talk of Hadoop, we are using Hive for that. Otherwise, we are if it's a non-Hadoop deployment, it's all the RDBMS or the relational databases are actually SQL format. And we discussed how we can store the same table in a NoSQL database, which is basically HBase when it comes to Hadoop, and how it can store data in a column-oriented manner. So the point here is that all these data is actually being stored in a column-oriented manner. We discussed quickly about that too, what exactly is a column-oriented. So when we talk of SQL format, each row is stored. If we see these as memory locations, we are storing data in the row format. So row by row we are storing. So starting from the first column of the first row, it is stored in the first memory location. Then the second column of the first row in the second memory location, third column of the first row in the third memory location, and so on. So we are storing in continuous memory location. We are storing data row by row. But the same picture is different when it comes to NoSQL databases because it's a column oriented. This kind of format is known as row oriented format. But when it comes to column oriented, continuous column we are storing one by one. So if first all the values of the ID column are stored in the continuous memory location, then the next column values are stored in the continuous memory location. Okay, starting from here, you can say if there are multiple columns, we are actually storing them first, then we are going to the next column. Okay, one by one we are storing the values. Then we see what exactly is the benefit of storing it in this way. So the benefit is that you can quickly access a particular row, or you can randomly access a particular row instead of traversing the whole data. Okay, so let's say if I wanted to randomly access the value of a row with ID 4000, I would not be required to traverse all these data points one by one and then reach, which was actually happening in the Hive or SQL formats. In here, I can quickly go to the memory location 4000 and get the information, and correspondingly, I can fetch the related values as well. Because everything is indexed, right? So I would know that okay, after I get the value 4000, what exactly is the next associated row values of that row and at what index are they present. So thus HBase makes it faster to randomly access data and to fetch the information. Okay, so now we discuss about the architecture of HBase. So you can install the HBase service in your clusters. Okay, so you just need to add service from the top left option, and just follow the whatever is being asked on the screen. And once you have added, you will see that these roles are present. But there will be one master. There won't be any backup master present at the first time when you install it, but you can add another master, and that will act as a backup master. So similar to how we have high availability in HDFS and YARN, we have high availability over here as well, wherein when you add another master, so there is a no separate uh, option to enable high availability in HBase. Okay, to enable it, you just need to add another master on a different server, and that will enable automatically the high availability feature of HBase. One second. Okay, so you just need to add two masters, or you just need to have two masters in the cluster, and that will automatically uh, well, act as a HA environment. Similarly, once you have added, you will see only one region server in the cluster. So you need to add two more on two different servers that you have. Okay. So this is basically an architecture of HBase. So you have a master or two master, one act as an active, other as a backup, and you can have multiple region servers. Okay. And Zookeeper also plays a role here. So Zookeeper will decide which of the masters will act as an active master at that time. Okay, so if this master stops responding, the zookeeper will give information to the other master, which is the backup one, and it will make it active. Okay, so the zookeeper decides the state of the master in here. Now, when it comes to master service, it's just like how we had in HDFS, which it was storing the metadata associated with the data which is actually being stored on the data node. Similarly, in here, the master will store the metadata of all the namespaces and all the tables that we have in the cluster. So I told you last time also in HBase, we also create tables, but those tables are actually placed in a container called namespace. And namespace, you can think it of as quite similar to a database in Hive. Okay. In here you have namespace, and namespace is that container which contains multiple tables that you create. Okay, so master will actually be storing about the metadata or the schema information of that table, or all the namespaces that you have in the cluster. Then comes the region server. So in HBase, all the tables are divided into regions. Okay, and the regions will have further different components within it, but yes, all the regions are grouped and can be stored on a single region server. Okay, so region server is actually the service which is storing the data or the regions uh, of any HBase table. Okay, so you can have multiple region servers because we are working in a distributed environment, so multiple region servers can have multiple regions assigned to them, And all this information about which region is stored on which region server, that is also being managed by the master. So just like in how the name node knows which block is present on which uh, data node, similarly here the master will know which region is associated with which region server in the cluster. And the regions that I'm talking about, ultimately every data field is present on HDFS only. Okay, so ultimately everything is on HDFS, but this is just like how we did in Hive. We have segregated, we have created an overhead of uh, schema associated with those data which is in HDFS layer, which will make us understand whether it's a HBase table or whether it's a Hive table. Similarly, in here, the HDFS layer is storing the actual data of the regions, and that static data which is present on HDFS is basically called a HFile, which we will discuss shortly when we discuss about each region. Okay. For now, you need to understand that each region server is having multiple regions stored in it, and the regions are actually storing data on the HDFS layer. So all these components, they constitute us the architecture of the HBase. Now let's talk about what is region. Okay, so each table that we have in HBase, it's divided into multiple regions. Okay, which is stored on the region server. Now region servers has its own architecture. Okay, so how exactly is region server storing things? So in a region server, you will find a single component which is common to the whole regions or every region that you have in the region server, which is called a val or a write ahead log. Okay, it's like a uh, it's like a recovery feature. It's a backup feature, you can also say. So every time when a data is being written to a region server or the regions are being written to the region server, that data will first get flushed to the val or the write ahead log. And the reason is that if somehow this region server goes down, we can still recover the data from the val and recreate those regions. Okay, so it's a recovery feature. If region server goes down, data can be recovered from the write ahead log, or if a region goes down, or if a region becomes offline, we can get the data back from the val. So the first time a region is being written, it will be written to the val. Okay, next this same region will be returned to the MemStore. Now this is a feature, MemStore is separate for each region. You can see here we have different MemStore for different regions, and the MemStore is like, it's like the dynamic memory, or the you can consider it as a RAM of the region. Okay, and after some time, this data will be flushed into a static file. Up till here it was dynamic or RAM, and data is sorted. So once you write data on a MemStore, it will get sorted. Okay, but the same data which is written on val, it is not sorted. Okay, so inside MemStore, data gets sorted, and once after a certain period of time, this data get flushed into a static file which is stored on the HDFS, which we call as a H file. So for long storage, for long time storage of data within HBase, you will find multiple H files are present on the HDFS layer. Okay, so you need to understand, first time when data is written, it is written to the val, and correspondingly it is also written to the memstore. Okay, in val data is not sorted, in memstore data gets sorted on, it can be on keys, column family, whatever it is. Okay? After a certain period of time, the data gets flushed into a static file on HDFS layer, which is called a HFile. Now there is another data structure which is associated, okay, uh, with the region server architecture, so which is called a block cache. Now this will come into picture when you are reading data from a region server. Okay? When you are reading a particular tool, uh, the block cache may come to picture. Block cache will contain information or the regions which are being read uh, or which are being read more often. Okay, so if you are multiple, if your queries are fetching multiple information from same table or from same region, that region will get stored into this in memory. This is also a dynamic memory or a RAM kind of a thing. It gets stored in the in-memory data structure of block cache. Okay, so data will, if you query the same data, instead of instead of reading the same data from H file, and that might take a little more time, you can query the same data from block cache, and that would be even faster. Okay, so in all, within a region server, you have a block cache and val, which are common to all the regions. Okay, block cache will contain information of regions which are being queried more often, while val is will use for pure backup purposes. You want to back up so a region which has gone offline, you can use the write ahead log. And within regions, you have their own MemStore and HFile. MemStore is it's also like an in-memory thing, wherein when you write data to it, uh, it gets sorted first, and then after a certain period of time, it gets flushed into HFiles. Okay, now let's talk about some of the HBase commands. Okay. So, although creation of namespace, creation of tables, or these things you might not be doing it as an admin, but you still need to know it, because uh, if an issue comes, you need to know the basics of it. So normally you can just type on your system server H shell, and it will open a separate shell. Okay. Different from the Linux terminal, you will have different shell for only to interact with the HBase that will open. On the HBase shell, you can create the container. So I was talking about the container, right? That's just like a database. So the command to create that is create underscore namespace followed by the namespace name. Right now we are naming the namespace as HB9. Okay. Then you can list all the namespaces with the command list underscore namespace. So these are all commands you have to run on the HBase shell. So first you have to type HBase shell. After that, another shell will open up. You can run these commands on those shells. Okay, and within a container, within a namespace, you can create a table. Right now, I created this table student 2, and you have to define a column family. So column family is basically it's a group of columns within a table. Okay, so you can have multiple column families. If you have, let's say, if you have uh, multiple columns you want to segregate into different groups, you can define multiple column families as well. Right now I just defined only one single column family called CF for this table. Okay, but we don't need to get into much details of what exactly it is, because these are mostly will be done by your developers. As an admin, The most important command that we will use while we are troubleshooting issues is the file system check. Okay, it's quite similar to how we used to do in with the HDFS also. So HDFS uh, has that command Hadoop FSCK, right, which was the HDFS file system check to check the status of regions and whether they are not offline or online. You can use the command HBCK or HBase file system check, and this command can also be used to repair any regions which are offline. Okay, so you can repair the regions which are offline also using the same. So simply you can just have to type HBase HBCK, and it will give you the status of the HBase, and if any of the regions are offline or they are not responding back, they will come as an inconsistency at the last part of the command run in the summary section. Okay, and if you want to repair, sometimes it's quite simply you just have to type -repair and it will remove those inconsistency. This repair option is actually a combination of multiple options, or it's a shortcut for these many options: fix assignment, fix meta, fix HDFS holes, orphans. So these are all different kind of issues that can come up: HDFS holes, HDFS orphans, HDFS overlaps. Within a region, a file can be overlapping, missing, or orphan, or version issues, reference files, table locks. So all these kind of issues which might be causing a region to go offline, you can use the shortcut -repair instead of mentioning them separately. The separate options, you can take a look at this. Okay, so you can separately also fix issues, but mostly you don't need to use any of these options. Just repair is enough. If anything is more serious, maybe you will have to consult or dig deeper and understand what exactly is the issue, and then you can choose among these options. Okay, so um, you can choose among any of these options for repair as well. Repair holes will only fix on the HDFS holes and assignments. Only focus on that. And if you want to just fix the table logs, when you will troubleshoot, when you will see the HBase logs and try to understand what is exactly wrong, you will find some hints that maybe there are HDFS holes in that region or something like that. So depending upon that, you can choose all these options with the FSCK. But if you only want to check the status of FSCK or HBCK, you can just type HBase space HBCK, and it will give you whether the cluster is healthy or it is having some inconsistencies within it. Okay, so that's all for HBase, you know, and I will request everyone to try add this service within your clusters. Okay, and once you add it, try to create a single namespace, a table. Commands are present in these nodes. And once you have created, try to run the HBCK and also check your HBase log. Again, every time e- each log file you associated with any service, you can find within this location var log. So right now we are dealing with HBase logs, so you can find the information in the HBase. And to check the regions information, you can check the region server log. To check the complete cluster information, you can see the master log. Okay, so try to take a look at these, open these logs files and also try to read them, what exactly is happening within each service, and also try to analyze the hpck command output. Okay, so that's all. I won't take much time today because we already, I see a lot of people have not joined. And in the next class, we will be starting with Spark and some of the Hadoop clients. What is a Hadoop client actually? And the most commonly used Hadoop client, which is Hue. Okay, and we will try to cover up Uzi. So these are very small topics. It won't take much time. What is Uzi scheduler? And we are using another scheduler as an alternative as Azkaban, which is not part of the Hadoop, but you should know about it because sometimes people can ask. And if time allows, we will start next week itself the backup concepts of HDFS. How do you backup and recover? So we will be discussing in it about the snapshots and the DR strategies. And finally, the most important topic will be security and Kerberos, which maybe we will have to do in the next week, and which will be our last topic. of the course. Okay, so these are the major topics which are left, and if you have any doubts, you can also discuss with me. Okay, so that's all for today. Any questions, Chandru?
Not really.
Okay, so let's meet next week, and we will start with Spark.
Yeah. The class will be on Thursday?
Yeah, Thursday itself.
Okay, all right.
Okay, thank you, Chandru. Good night. Bye.
Thank you.